In this video, we're going to learn how to use the sensitivity analysis features of ATRisk. The model that you're looking at estimates the cost of dredging. The cost is based on the idea of removing a cubic yard of material from beneath the water. The value that you're looking at here randomly is $3.09. This is a proprietary model I'm not able to share with you, but I can show you how this works. Notice the inputs include such things as looking in row 19 and 20, contractor's overhead, contractor's profit, the amount of material that we are estimating you will have to remove, and then the constitution of that material, mud and silt. That's factor 3 is so soft it could probably be removed by a straw, and we move all the way down to rock so hard that it must be blasted. And so you see what percent of the material being removed comes from these various categories. And then there is, of course, the necessity of getting that material that you remove to the place where you're going to dispose it, and that's when we get into pipeline considerations, particularly the distance that you're going to have to transport the material. There is the production, the actual pumping, the number of boosters that you use, what percent of the month you are actually able to pump. That varies with weather and traffic disruptions and all sorts of other things. And it goes on with other factors as well. So there are a great many factors in here that become important, including the fuel price. For those of you who are feeling nostalgic for the old days, this model was developed back in the year 2000 when the price of gas was rather inexpensive. As a matter of fact, back at that time, when folks were trying to imagine the highest price per gallon of gas, it was $1.30, as you see here. So what we have is another model that has uncertainty. So as I click my way through here, if I turn on the Monte Carlo process, you can see the percentages change, the values. We keep going back to the expected values every other iteration because of the inability of my video software to play well with ATRisk. But here's what we're interested in, of course, is this number here. So we're going to do 10,000 quick calculations of this value. And what we would like to know is, of all of the things in this model that contribute to uncertainty, which are the most important? And so you'll see a different graph here. Our goal is going to be to understand this graph by the time we're finished. But I'm going to wait now. I'm going to go back to the more familiar view that you have seen before. And this is what a typical output looks like. It says we don't really know what the unit cost of dredging is. It's somewhere between $2.31 and $4.15. Our best estimate is about $3.07. So we see a pretty wide spread there, a lot of variation in this output. And that may be important at times. And so risk managers, bosses, even yourself may ask, is there any way that I can narrow this distribution? Now, hopefully you understand that to the extent that the things we're looking at here vary because of knowledge uncertainty, the answer could be yes. If I had better information, perhaps I could reduce the range of this distribution. I could reduce the variation in this output. But to the extent that it's natural variability, I cannot. So what we're going to do is we're going to use an ATRisk feature here. If you look down at the bottom of this output, I'm now pointing to an icon, a tornado graph. And when I click on that, you'll see I have several options. We'll explain each briefly, but I'm going to just first go to the regression coefficient option. And I'm going to click on that. And this brings up a new display of that data. It's showing us which inputs in our model contribute the most to the variation in the output of this model. Notice that we have a horizontal scale here that goes from -1 to +1 if we had the entire scale plotted here. In the middle is a 0 point. So any value to the left of the 0 point is negatively related to our output. So mud and silt is negatively related to the unit cost. What this is telling us is the more mud and silt you have, as mud and silt gets bigger, the unit cost gets smaller. Okay? Basis of production. You're going to find that that could be confusing, so I'm going to show you another way that you want to look and make sure that you can trace your variables back to the proper inputs. Because if you do not specifically give a cell a name, ATRisk will name it for you, and sometimes it can be confusing. But let's go down to current fuel price for a moment and notice that that bar moves to the right. There's a positive relationship between fuel price and unit cost. So this is telling us that as the fuel price goes up, the cost per cubic yard of dredging goes up. So I would like you to be very clear on that in reading this particular graphic. Values to the left are negatively related to the output. Values to the right are positively related to the output. I'm going to close this now for the moment. I'm going to go up here into the ATRisk results cluster, and I'm looking for this icon here, simulation sensitivities. When I click on it, I have only one output identified, unit cost. In other cases, you might have more than one output, so you need to make sure you select the correct output. Change in output mean I will come back to. Let me go to the regression coefficients for the moment. And this is giving us the values that we were just looking at. But here's what I want you to see. It says of all the cells in this model, the one that contributes the most to the variation in the output is mud and silt, found in cell H42. H42 happens to be right down here. So if we can get a better estimate of that number, and that is a piece of knowledge uncertainty, because there is an actual amount of mud and silt in the bottom of this waterway. So if we can find out what that is, we can get a better estimate of the unit cost. The second most important contributor is the basis of production. But what's important for us to be able to do is to find this cell, and that's B74. So as I scroll on down here, notice here's where the words basis of production appear. But the actual basis of production, B74, is right here. So it's very important that you be able to trace to the actual cell. The current fuel price is found in this cell, and you would find all the other corresponding quantities found in the cells designated here. The regression coefficient is a normalized value. It's normalized over the scale of from 0 to 1. If you would like to see the actual values, you would use mapped values. So this is giving us, excuse me for that little interruption, this is giving us the actual values, not scaled over 0, 1, but this is giving us the impact on unit cost in dollars and cents. If you prefer, you can use the correlation, and that is the Spearman correlation. And you also have the option to use a change in an output statistic. Right now I have a change in the mean. And this, you see, mud and silt is still the highest rank there, and this is telling us that mud and silt accounts for a 60-cent change in the average price of the unit cost. So that's the range of its impact. The basis of production, those hours of the month, 66.6% of the hours of the month that you can actually pump, That counts for a swing of 55 cents.